Hello, welcome back. With this video, we'll start the fifth unit, that is lasers and fiber optics. In this video, we'll discuss the laser beam characteristics. Before understanding the laser beam characteristics, let us see what is a laser. A laser is a source of light. Like other sources of light, laser is also a source of light, but with certain special characteristics. We shall discuss those characteristics in this video. Further, laser is an acronym for light amplification by stimulated emission of radiation. It is an acronym for light amplification by stimulated emission of radiation. When we say light, it is a source of light. Lasers for short are also called as light amplifiers because they amplify the light. And how the amplification is done, the method used in amplifying the light is stimulated emission of radiation. We know that when matter interacts with radiation, stimulated absorption takes place, spontaneous emission can take place, further stimulated emission also can take place. In the light amplifiers or in lasers, the principle involved is stimulated emission of radiation. Now we shall look at the important characteristics of a laser. Laser beam characteristics. Important characteristics are directionality, very small divergence, high intensity, high degree of coherence, high monochromaticity. These are the 5 important characteristics of a laser beam. A laser beam is highly directional, its divergence is very small, intensity is very high, it has high degree of coherence, and it has high monochromaticity. We shall discuss one by one. Directionality. Suppose we have a conventional source of light, maybe a torch light. When you switch on the torch light, the light beam emerging from the torch light would diverge. Means the area of cross section of the beam increases quite fastly. As a result, the intensity also drops down because the same radiation intensity should be distributed over a very large area when the separation between the source and the place where we want to study the intensity is large. While in the case of a laser, if you have a laser like this, the laser beam would always move as a straight line in one particular direction. So the laser beam is highly directional. Generally, to obtain a directional beam from an incandescent lamp or a sodium vapor lamp, we use a slit. A slit is generally used to obtain a directional beam from a nearly coherent source of light, such as sodium vapor lamp. The laser beam is highly directional because, in case of laser, active medium is in a cylindrical resonant cavity. Active medium is in a cylindrical resonant cavity or a resonator. Therefore, any light that is traveling in a direction other than parallel to the cavity axis is eliminated, and only the light that is traveling parallel to the axis is selected and reinforced, because sustained oscillations in the cavity can take place only when the beam of light is parallel to the axis of the cylindrical resonator or cylindrical cavity. Only the light that has sustained oscillations along the axis of the resonator will emerge out in the form of a laser. Therefore, the beam that comes out of the laser will be highly directional. In case of a laser, the active medium is taken in a cylindrical cavity. Light that is traveling parallel to the axis can only have sustained oscillations in the cavity other than parallel to the axis are eliminated. Why they are eliminated? Because the light that is not parallel to the axis of the cylinder cannot have sustained oscillations. As a result, they will vanish or their intensity decreases rapidly and eventually it becomes zero. Therefore, the laser emits in only one direction. Next, we shall look at the divergence. Divergence essentially means spreading. Consider this as a point source of light. When you have a point source of light like that, then light will be emitted in all possible directions. Therefore, the divergence is maximum. At the same time, when you have a laser, the laser beam divergence is negligibly small because laser generally emits plane waves. Since it is emitting plane waves, the light beam essentially remains as a bundle of parallel rays. The small divergence in the laser beam is attributed to the diffraction of the beam at the exit mirror. A typical helium neon laser will have a divergence is about 10 power minus 3 radians. It means that the diameter of the laser beam increases by about a millimeter for every meter it travels. Mathematically, the divergence can be calculated using phi is equal to d2 minus d1 upon L2 minus L1, where d1 and d2 are diameters of the beam of the spot measured at L1 and L2 distances from the source. Suppose if you have a source of light like this, a laser, we place a screen at say a separation of L1, the spot of the laser on the screen whose diameter is d1, and if you move the screen to some other location, say L2, when the screen is at L2, if the spot size is slightly bigger, then you call it as d2, and the separation is L2, then the divergence is given by this formula. Phi is equal to d2 minus d1 upon L2 minus L1. Typically for lasers, the phi value will be in milliradians. The next aspect we discuss is the intensity. The intensity of a light from a conventional source decreases rapidly with the distance as it spreads out in space. The laser emits light in the form of a narrow beam with its energy concentrated in a small region of space. Therefore, the beam intensity would be tremendously large and stays constant with distances. The intensity of a laser beam is approximately given by I is equal to 10 over lambda square into P, where P is the power radiated by the laser. The intensity of a laser is many number of times more than the conventional sources of light. It is a source of very high intensity of light. Now we shall discuss the coherence. A lamp is a source of incoherent light, whereas the laser is a coherent source of light. Coherence essentially means reproduction of the wave pattern at one point of time and space to any another point of time and space. There are two different types of coherences: spatial coherence. The second one is temporal coherence. Laser beams generally possess both spatial and temporal coherences. The distance over which the coherence exists in space is called as coherence length. Coherence length is the distance over which the wave remains coherent. Typically for a sodium vapor lamp, it is about 0.3 millimeters. On the other hand, for a helium neon laser, it is about 100 meters. Next we shall discuss monochromaticity. Monochromaticity essentially means having single color. Mono means single, chromo means color. So it is having single color. Or if light coming from a source has one frequency of oscillation or single wavelength, then the light is said to be monochromatic. And the source as a monochromatic source. The source is called as a monochromatic source of light. In the case of conventional sources of light such as sodium vapor lamp, the monochromaticity, it spreads over 10 nanometers to 100 nanometers. While in the case of a laser, the spread is less than 0.1 nanometers. If light emitting from a source has only one frequency of oscillations or one wavelength only, then light is said to be monochromatic. The characteristic of producing one wavelength or one frequency of oscillation from a source of light is called as monochromaticity. In the case of sodium vapor lamp, the wavelength drifts from 10 nanometers to 100 nanometers. In the case of a laser, the wavelength spread less than 0.1 nanometers. In this video, we have started our discussion by understanding what is a laser. We have said laser is a source of light with certain special qualities. Further, we have said laser is an acronym for light amplification by stimulated emission of radiation. We have listed out the important characteristics of the laser beam. We have discussed the directionality of the laser beam. We have seen the divergence in the case of a laser beam. We have seen how to calculate the divergence. We have seen the intensity of a laser beam. We have seen what is meant by coherence, and we have said that two different coherences are possible. One is spatial coherence, the other one is temporal coherence. Sodium vapor lamp will have coherence length of about 0.3 millimeters, whereas the helium neon laser will have coherence length of about 100 meters. We have seen what is monochromaticity. We have said that general sources of light, they will have a spread of wavelength from 10 nanometers to 100 nanometers, while the spread in the case of a laser is less than 0.1 nanometers. Thank you.